Hey everyone, this is Yaswanth. Welcome to Yaswanth IT. If you are watching our channel for the first time, don't forget to like this video and subscribe to my channel.
Yeah, the most very important JVM, JVM and JVM architecture and what this JVM contains. Okay, let's see what is JVM. JVM stands for Java Virtual Machine. Virtual, okay. Virtual means we can't see our eyes. This JVM will be a part of JRE, Java Runtime Environment. This Java Virtual Machine will be a part of Java Runtime Environment. Okay. Only this JVM will be executing our Java program. Without JVM, we cannot execute our program. Okay. JVM stands for Java Virtual Machine. We cannot see with our eyes. And JVM will be a part of JRE software. What is JRE? Java Runtime Environment. JVM is responsible for executing Java programs. Okay. JVM will allocate memory, deallocate memory. Okay. In C earlier we discussed in C we need to specify the size of our primitive data types and okay, but in Java we don't need to specify our primitive data type size. Our JVM will be responsible to allocate and deallocate memory. Okay, memory allocation will be done in at the time of program execution and will to allocate and deallocate memory. Okay, JVM will convert bytecode into mission understandable language. Okay, uh, JVM will convert our generated bytecode into mission understandable format. Okay, see, very important JVM architecture. JVM architecture. How JVM will work internally. Okay, first of all, see here. This is a Java program which contains source code. After compilation by using Java C command, it will generate a bytecode. Okay, this will generate a bytecode with which will contains dot class file as an extension. Dot class as an extension. When we execute this dot class file by using Java command, it will call JVM. Okay, JVM will be come into picture. JVM will perform this all the bytecode. It will load by using class loader. Okay, by using class loader, all the bytecode will be loaded into this JVM. Okay, class loader will be different like exclusive class loader, bootstrap class loader. Like there's some different types of class loaders. We will discuss in upcoming session. So okay, this class loader will load all our bytecode into this JVM. See here in JVM there are different types: method area, heap area, Java stack, PC registers, native stack, native libraries, native interface, and all these two components will come to execution engine. In execution engine, it contains interpreter and JIT. Okay. Whenever the class loader load our bytecode into JVM, all the bytecode will store in method area. All the all the bytecode will load into all the bytecode will load and store in this method area. And this heap area will contains uh, whatever we created our objects, all those objects will store in this heap area. And Java stack. All the all the methods we created in our program will be loaded into Java stack. Okay, okay. This Java stack contains all our methods, whatever we created. What is a method? We will discuss in upcoming session. Okay, what is Java stack? In this Java stack, Java stack is a component which is available in JVM. This Java stack contains all our methods. In methods only we can write our business logic. Okay, all our operations will perform only in methods. Okay, that method information will be stored in Java stack. And what is PC register? This PC register will store the next line of execution. Okay, the next line. What is the next line to execute? This PC register will store that information in this PC register for performance optimization. Okay, and native stack. What is this native stack? All the non-Java code, all the non-Java code will store in this native stack. This native stack will connect to native libraries and native interface. This native libraries and native interface, based on this native libraries and native interface, it will load whatever the packages this non-Java code contains. All the non-Java code packages will be loaded from this native libraries and native interface. Okay. After this, all the performance, it will come to execution engine. In this execution engine, there is two. There are two. One is interpreter and another one is JIT. Interpreter will convert, will execute line by line. Okay. And this JIT, what is this JIT? Just-in-time compiler. It will execute. It will compile this program in time. After that only we will getting output. See here, earlier we created we compile this program. After this compilation, one dot class file is created. Based on that dot class file, we are execute this program. After this program, it will load dot class file. Okay, it will load dot class file here. This dot class file, this dot class file contains bytecode. All the bytecode will store in this method area, and all the objects will be stored in heap area, and this Java stack will store our main method area. Here we created a main method. Here in our program we created a main method. This is a main method. This main method will store in Java stack. Okay. Uh, After that PC register. What this PC register means? It will store if our program will running compiling this line. It will store upcoming line. Okay, upcoming line. It will store in PC register. Okay, it will uh, gives us performance optimization. And what is this native stack? It will all the non-Java code. It is going to store in native stack code. It will also contain some packages and predefined libraries. All the needed libraries and packages are loaded from this native libraries and native interface. And all the performance, it will come to execution engine. After this in execution engine, interpreter and JIT will compile our code. Then only we are getting this output. Okay, then only we are getting this output. Okay, this much internal execution is there in JVM. Okay, see here, class loader. It will load dot class file into JVM method area, class code, whatever the byte code, it will be stored here. Heap area. What are the we created objects in our program? What is object? We will discuss in upcoming session. Okay. What is the object? Object will be stored into heap area. What is Java stack? Method execution. What are whatever we created our methods, it will store a method execution information. It will be stored here in Java stack. PC register. It will maintain next line information to execute. Okay. It will maintain next line information to execute. And what is native stack? It will maintain non-Java code. Okay, non-Java code execution information is stored in native stack. What is native interface? It will load native libraries into JVM. Okay, it will load native libraries. Whatever the non-Java code libraries, native libraries, it will load into JVM. And it will also load Java library, native libraries also into JVM. Native libraries, non-Java libraries will which are required for native code execution. What is native code? Non-Java code. What is native code? Non-Java code. It will store in native stack. So native libraries, non-Java code libraries which are required for native code execution. Okay, and execution engine. It is responsible to execute the program and provide output. It is used internally interpreter and JIT for execution. Okay.